Welcome to Math with Mrs. Bibb. Today we will be solving linear and absolute value equations and inequalities. First, I want to define equation. An equation is a mathematical sentence stating two mathematical expressions are equal. A mathematical sentence stating two mathematical expressions are equal. A solution is a value that makes the equation true. And a root is also called a solution of an equation. And zeros are the x-intercepts of a graph. Also written as f of x equals 0 or y equals 0. We're going to solve a few equations, and this will be a review of things that you've learned earlier in your educational experience. I want to point out something that students told me that their teachers had told them in their early grades. When you're solving an equation, after you take care of parentheses, a linear equation, you won't have an exponent other than 1. But when you're solving an equation after you take care of parentheses, you're actually doing PEMDAS backwards. You take care of your addition and subtraction first. So you do this first, and then you multiply or divide. So I think that's a great way to look at it and a great way to think about it. When you're solving an equation, a linear equation, after you take care of your parentheses, then you are doing PEMDAS backwards. Our first equation is 1/3 times the quantity 2x minus 57 plus 1/3 times the quantity 6 minus x equals -4. The first thing I'm going to do is to distribute. One-third times 2x is 2/3 x. 1/3 times 57, 3 goes into 57, 19 times. So if I multiply 1/3 times -57 over 1, that would be -57 over 3, which is -19. Plus 1/3 times 6, 1/3 times 6 over 1 is 6 over 3, which is 2, minus 1/3 x equals -4. Next, I'm going to combine like terms. 2/3 minus 1/3 is 1/3 x. -19 plus 2 is -17. I'm going to add 17 next, working that PEMDAS backwards. 1/3 x would equal 13. I'm going to multiply both sides by 3, so x will equal 39. That's the answer to number 1. Number 2, an easy one from a long time ago, 3x minus 10 equals 4 minus 5x. I'm going to add 5x first. Many teachers will tell you to move the smallest variable to the largest, and negative 5 is smaller than 3. That should give you a whole number. 8x minus 10 equals 4. Add 10. 8x will equal 14. Divide by 8. It does not work out evenly, so we'll leave it as 14 over 8 and divide both of these by 2. So 7 over 4 is my final answer there. Number 3, 5/6 k plus 2/3 equals 7/12. Many students have told me that their teachers tell them to find a common denominator first, and that will make life much easier. So as I look at 6, 3, and 12, the common denominator would be 12. Six times 2 equals 12, so I'll multiply 5 times 2. 3 times 4 equals 12, so I'll multiply 2 times 4. 12 times 1 is 12, so I'll multiply 7 by 1. So 5 times 2 is 10. 2 times 4 is 8. 7 times 1 is 7. Now I will subtract 8/12 to the other side. 10/12 k equals negative 1/12. I'm going to multiply both sides by 12. That means 10k equals negative 1, and divide by 10. K will equal negative 1/10. That should be the answer to number 3. Now for number 4, we have a word problem. The diameter of Earth is 828 kilometers less than, so 828 kilometers less than twice the diameter of Mars. So D is the diameter of Mars. So I'm defining my variable. And Earth has a diameter of 12,756 kilometers. So the first thing I'm going to do is add 828 to both sides. 14, 7, 8, 15, 13,584. Oops, I don't need that comma there. Equals 2D. I'll divide by 2. So D will equal, 2 goes into 13 6 times. 6 times 2 is 12. 13 minus 12 is 1. 2 goes into 15 7 times. 7 times 2 is 14. 15 minus 14 is 1. 2 goes into 18 9 times. And 2 goes into 4 2 times. So I hope that's right. Now I'm going to answer this. A word problem should have word answers. I think I'll answer it here. I think you have enough space underneath yours. I would say the diameter of Mars is 6,792 kilometers. That would be my answer to number 4. For number 5, it says find the related function and solve by graphing using Desmos. The first equation that we will find the related function for is 1/2 x minus 11 equals negative 8. Now what this means, find a related function, that means make this equation equal 0 and replace that equal to 0 with f of x. So I'm going to add 11. I decided not to add 11. It would be faster if I add 8. So 1/2 x minus 3 equals 0. So my function is f of x equals 1/2 x minus 3. And I'm going to graph that using Desmos. 1 half x minus 3. And hopefully from discussions in the classroom, you know that the solutions are the same thing as the roots, which is the same thing as the zeros. So I'm looking for the x-intercept. And in this case, my x-intercept would be 6. So I would say the answer is x equals 6, just by making it equal 0, putting it into Desmos, and finding where it crosses the x-axis. So somewhere you're going to want to write where graph crosses the x-axis. That is what your solution is. Letter B, 2x minus 5 equals 8. I'm going to subtract 8. 2x minus 13 equals 0. So f of x, or I could use g of x, equals 2x minus 13. I'm going to type it in Desmos now. Hopefully. 2x minus 13. 2x minus 13. .5, so x equals 6.5. So if you were taking a standardized test and you had a graphing calculator available, you do not need to know how to solve that. You can make it equal 0 and type it into the graphing calculator and find where the graph crosses the x-axis. Going to add 11. So f of x equals 2x plus 6. I'll type this one in. Oops. -3. X equals -3. And we solve those equations by making the related function and graphing. Linear inequalities. So for linear inequalities, you solve them the same way you solve an equation, except if you multiply or divide by a negative number, you flip the inequality. We will be writing answers of inequalities in interval notation. I believe the textbook writes them in set builder notation, but we're going to write them in interval notation. So we'll graph and then write in interval notation. So my first equation, m divided by -2, is less than or equal to 5. I'm going to multiply both sides by -2. M will be greater than or equal to -10. Graph that on a number line. It does not have to be graphed fancy. I'm going to put 0. I'm going to put -10. Solid circle. Shade to the right. And then as I read this number line from left to right, where's my red number line start being shaded green? At -10. It has a closed circle, so you put a bracket. Where does it stop being shaded green? At infinity. And that's my answer to number 1. The textbook will have, and you don't have to write this down, but the textbook will have m such that m is greater than or equal to -10. Number 2, 4h minus 3 is greater than -15. I'm going to add 3 first. So 4h is greater than -12. Divide by 4. H is greater than -3. On a number line, open circle on -3, shade to the right. Read this number line from left to right. Where does it start being shaded? It starts at -3 with an open circle. And where does it stop being shaded? Positive infinity. That's my answer. Then number 3, 14 minus the quantity w plus 4 is greater than or equal to -5 times the quantity 2w plus 3. I'm going to distribute my negative and distribute my -5. So 14 minus w minus 4 is greater than or equal to -10w minus 15. 11 is greater than or equal to -10w minus 15. I'm going to add 15 to both sides. So 26 is greater than or equal to -10w. Divide by -10. -2.6 is less than or equal to w. Oops, I put an m. W is greater than or equal to -2.6. On number line, here's 0. I'm just going to put 2.6. And it will be a solid circle and shade to the right. And I'm sorry, all of those examples were greater than or equal to. From 2.6 with a bracket to positive infinity. Next, we're going to talk about absolute value. If you'll fill in the definition, please. It is the distance a number is from 0. The equation of absolute value looks like this. Absolute value of A plus B equals C. And I want to go through the steps with you. So step 1, your absolute value must be alone. Please write all these steps down. And what I mean by alone is there can't be a number out here being multiplied. There can't be a number out here being subtracted or added. You would have to add or get rid of this by adding or subtracting, and get rid of this by dividing. So this absolute value has to be alone. Step 2, the number on the right must be positive. That's where that C's at. The number on the right must be positive. If not, the answer is no solution. Step 3, write two equations with or in the middle. I did not say write two absolute value equations. I said write two equations with or in the middle. So I want to demonstrate that. Pretending as if this is a positive. We know it's a positive, and we know this is a lone. Then we can write our two equations with or in the middle. We would write A plus B equals C, or A plus B equals the opposite of C. So that's what I mean by the two equations. I want you to notice that these are always the same as what's in the absolute value. If you need to, make a note of that. What is the same? These stay the same. You do not change that sign. But it is that this is equal to a positive C and this equals a negative C. Because the absolute value of C is C, the absolute value of negative C is still C. So be clear that you do not put absolute value in this step, and you do not change the sign of what's in the absolute value. You only change the sign of the number that's on the outside. Step 4, solve each equation. And step 5, check for extraneous solutions. Those are the steps to solve an absolute value equation, and we will do some examples now. Number 1, and we are just solving. I don't think we have to graph, but we are just solving. Number 1, the absolute value of 5x plus 4 is equal to 24. Let's go through the steps. Number 1 is our absolute value alone. Is this alone? Yes, it is. Step 2, is the number on the right a positive? Yes, it is. Now I'll go to step 3. It says to write two equations. Take what's in the absolute value out. It doesn't change. Set it equal to 24. Or take what's in the absolute value out. Set it equal to negative 24. Solve each of these. X will be 23 over 5. Or solve this one. 5x equals negative 25. Divide by 5. X equals negative 5. And we could check these for extraneous solutions, but I do know that both of these answers work. So I'll put negative 5 and 23 over 5. I'll show you where it's absolutely necessary that you check for those extraneous solutions. Number 2, 2 times the quantity, or 2 times the absolute value of 5x plus 1 minus 9 equals 4x plus 17. First thing I'm going to do is add 9 because I need that absolute value up to be alone. 2 times the absolute value of 5x plus 1 is equal to 4x plus 26. Next, I'm going to divide by that 2 that's on the outside because I cannot have that number out there. So the absolute value of 5x plus 1 is going to equal 2x plus 13. Now, when you have an expression, I don't know if this is positive or negative. It depends on what x is. So this would be one of those that you have to make sure to check for an extraneous solution. To solve this type of equation, you do your two equations, right or in the middle. 5x plus 1 equals 2x plus 13, or 5x plus 1 equals the opposite of 2x plus 13. Solve. I know you know how to solve an equation. 3x will equal 12. Divide by 3x equals 4. And the next one, I'm going to distribute this negative sign. 5x plus 1, negative 2x minus 13. I'm going to add 2x. 7x plus 1 equals negative 13. Subtract 1. 7x will equal negative 14. Divide by 7. X will equal negative 2. Number 3. 2 times the absolute value of x plus 1 minus x equals 3x minus 4. I've got to get this absolute value alone, so I'm going to add x and then divide by 2. 2 times the absolute value of x plus 1 equals 4x minus 4. Divide by 2. The absolute value of x plus 1 equals 2x minus 2. And again, I do not know if the number on the right is positive or negative. I must solve both of those equations. X plus 1 equals 2x minus 2, or x plus 1 equals the opposite of 2x minus 2. I'll solve this first one by subtracting x. 1 equals x minus 2. I'll add 2, so x equals 3. Or distribute that negative sign. X plus 1 equals negative 2x plus 2. I'm going to add 2x. 3x plus 1 equals 2. I'm going to subtract 1. 3x equals 1. I'm going to divide by 3. X will equal 1/3. If I substitute this answer in to my original, or even here, it will work. So 3 is a solution. If I substitute 1/3 into either of these, I'd have 4/3 minus 4, or I can go even down here, 2/3 minus 2, which would give me a negative answer. Therefore, that means that this is an extraneous solution, and my only solution here is 3. Now, explain one more time, extraneous. And I am going to go back to where I isolated this. The absolute value of x plus 1 has to equal a positive number. If I use 1/3 as my x value, then 2 times 1/3 is 2/3. And a fraction minus 2 is going to give me a negative number. That would be negative 1 1/3. And that would be no solution. So this one would be an extraneous solution. And if I put 3 into this problem, 2 times 3 is 6, 6 minus 2 is 1, and 3 would work. So I just have to remember that. And then for number 4, the absolute value of 4x minus 7 plus 10 equals 2. I have to get my absolute value alone. I'll subtract 10. So the absolute value of 4x minus 7 equals negative 8. And I have my absolute value alone. The number on the right is not positive. Therefore, my answer is no solution. For number 5, sorry, that screenshot does not look very clear. It's typed on your paper, or that picture's on your paper, so hopefully that will be clearer for you. It says the NFL regulates the inflation or air pressure of footballs used during games. It requires that footballs have an air pressure of 13 pounds per square inch plus or minus 0.5 psi. What is the greatest and least acceptable air pressure of a regulation NFL football? We could use basic math to figure that out, but they want us to learn how to write an absolute value equation. So that absolute value equation is always written as x minus. In this spot, you put the mean. Sometimes it's given to you. Sometimes you have to do a plus b divided by 2. And then it equals the distance from the mean. Well, in this circumstance, it's given to us. The mean air pressure is 13. So x minus 13 equals 0.5. That's how far it is from the mean. And then they want us to write the two equations, x minus 13 equals 0.5, or x minus 13 equals negative 0.5. I'll add 13. So x will equal 13.5, or add 13, x will equal 12.5. So to answer this in a complete sentence, the greatest acceptable air pressure is 13.5 pounds per square inch, and the least acceptable air pressure is 12.5 psi. Next, we're going to talk about absolute value inequalities. In Algebra 1, you did compound inequalities before you did absolute value inequalities. And so instead of reviewing those compound inequalities, I'm just going to jump right in. I'm going to remind you that if you have less than, or equal to, these are an and inequality. An and, when graphed on a number line, will always look like this. And when you have these inequalities, greater than or equal to or greater than, and graphed on a number line, they will most always, and I said always on that previous one, but it may not always be true. So there are exceptions to most rules in mathematics, not all, but to many. And so for this one, it's an or, and it's typically graphed going away from each other. And one key thing to remember, before you can decide if you have an and or an or, your absolute value must be alone, just like when you're solving an equation. Oops. We'll do some examples. The first one I'm going to do is the absolute value of 4x minus 8 minus 5 is less than 11. My absolute value is not alone, so I'm going to add 5. The absolute value of 4x minus 8 is less than 16. This is less than, so it's an and. We're going to write the word and we're going to say 4x minus 8 is less than 16, and 4x minus 8 is greater than negative 16. So not only do you put a negative sign on that number, you also flip the inequality. You solve both of these. 4x is less than 24. Divide by 4. X is less than 6. And add 8. 4x is greater than negative 8. Divide by 4. X is greater than negative 2. When you have and, it should be written, I'm going to put it in set builder first, x such that you should put your x in the middle. It's an interval between those two numbers from negative 2. X is greater than negative 2. Read that from right to left. And x is less than 6. I'm going to draw a number line. I'm going to show you what that looks like on a graph. From negative 2 to 6, open circles, shade in the middle. And then in interval notation, that is from negative 2 to 6. Number 7, we're going to do the absolute value of 6x plus 3 divided by 2 plus 5 is greater than or equal to 14. I'm going to subtract 5 first. So the absolute value of 6x plus 3 divided by 2 is greater than or equal to 9. Get rid of dividing by 2 by multiply by 2. I would have the absolute value of 6x plus 3 is greater than or equal to 18. And then I'm going to write my two problems. 6x plus 3 is greater than or equal to 18, or 6x plus 3 is less than or equal to negative 18. 6x is greater than or equal to 15. Divide by 6. X is greater than or equal to 15 over 6, which 3 goes into both of those, so 5 over 2. Subtract 3. 6x is less than or equal to negative 21. Divide by 6. X is less than or equal to negative 21 over 6. 3 also goes into both of those, which is negative 7 over 2. In interval notation, that would be x such that x is greater than or equal to 5 over 2, or x is less than or equal to negative 7 over 2. You do not join those. Here's why. Watch what happens. X is greater than or equal to 5 over 2. Greater than or equal to 5 over 2. And less than or equal to negative 7 over 2. And is the intersection. I'm going to write that in green. And is the intersection of where the shading would cross. And or is the union. So please make sure you write that down. And is the intersection, or is the union. So where these two would intersect, the shading of those two would be in this area, and these two would not intersect. You just put their shadings together. So or is the union, and is the intersection. And interval notation, from negative infinity to negative 7 over 2 with a bracket, union, bracket, 5 over 2 to positive infinity. And then my last example, number 8, I'm going to have negative 8 times the absolute value of x plus 14 plus 7 is greater than or equal to negative 17. I am going to subtract 7. And right now this looks like an OR problem, but watch what happens. Negative 8 times the absolute value of x plus 14 is greater than or equal to negative 24. Divide by negative 8. I divided an inequality by a negative. Therefore, that means greater than or equal to must switch to less than or equal to, and negative 24 divided by negative 8 is positive 3. Write my two equations. X plus 14 is less than or equal to 3, and x plus 14 is greater than or equal to negative 3. Solve. X is less than or equal to negative 11, and x is greater than or equal to negative 17. So in interval notation, x such that x goes in the middle, less than symbols on either side, less than or equal to negative 11, greater than or equal to negative 17. And then on a number line, I'm going to put negative 17, negative 11, solid circles. The intersection would be here. The shading goes together. And in interval notation, my answer would be from negative 17 to negative 11. And that's the answer, and that's all of my notes. I hope you have a wonderful day.